Our design problem is young children and students using smartphones at times when they shouldn't be, such as a young child trying to go to sleep or a student working on an assignment. A Korean study determined that smartphone overuse negatively correlated with total sleep time and overall demonstrated that due to younger children's lack of self-control, unchecked smartphone use can easily lead to addiction and problematic behaviors, which can potentially result in lower social skills and emotional control. Our solution for this problem is a timer-driven lockbox device shaped similar to a toaster. The functional requirements of this device includes the ability for the device to charge the phone while it's locked inside, keeping the phone secure until its intended release, an NFC system for manual release of the phone in an emergency, and an overall child-appealing look and design. An intended use case for this design would be a child locking their phone in the lockbox right before bed, removing the temptation to stay up and use it instead of sleeping. The lockbox timer would be set for such a time that the phone is released and fully charged when the child wakes up.
Now onto the hardware demonstration, which begins with a quick view of our whole setup, consisting of a Raspberry Pi, a motor and a magnetic circuit, and output by a screen and controlled by a rotary encoder. We can see that the screen tells the time and the amount of time left for the timer to end, and is controlled by the rotary encoder, as I mentioned earlier. Now the screen is connected to the Raspberry Pi through an HDMI, and a micro USB powers it. Here we have a quick look at the Raspberry Pi. The ToastBox charges phones through a wireless charger and is supported by a backup battery. The system charges through a wall outlet but is designed to run on its own power, both for mobile use and in the event of an electrical emergency where there is no power for the user. Which we can see here that the screen is still on when the wall outlet no longer delivers power.
So we've got the Raspberry Pi here. It's connected to the various pieces of equipment in the system using the GPIO pins. As you can see, the very first component would be the motor. It is using these GPIO pins to connect with the height bridge here, which then lets you go backwards and forwards in the motor up here, and it lets you lock and unlock the locking mechanism in the toaster. So that's lock, that's unlock, lock, and that locks it, stopping from anyone from using the phone in the toaster. So next is the magnet, which is the plunger. So yeah, so GPIO connects through the magnet. It's an electromagnet, and then it can run up through this transistor. And so pretty much this GPIO pin connects to Raspberry Pi, and you can, once the timer is turned off or the NFC emergency is taken out, it will turn off this and cut the current from ground, which is the third pin on the top, and it will pretty much cut the circuit. So to check if the magnet is on, these two complete the circuit for the magnet between this red wire, which is pretty much 3 volts, goes down into this brown wire, and then goes straight into a GPIO pin. And then and then that can test if there's any current running through the circuit, and so we can run any tests using that circuit. Okay. To cool all the airflow up through the Raspberry Pi, we put a fan at the bottom of the thing, which is secured, and yeah, so that keeps it cool. So now the GPIO pins are also connected to this circuit here, and all these wires connected by this all the way across to this perforated board, and this controls the time and when it is starting. So to program all our stuff, we mainly use Python 3. To create our GUI, we mainly use tkinter, which pretty much shows up all the GUI interface.
We begin this demonstration with our toaster with its shell on, and we see that our phone is beginning at 74%. Ideally that should change after our locked time. Now we need to decide how much time we put on, and We use the wheel to set 5 minutes. We push down the lever to activate the magnet, but the system is only activated once you click the button, which we can see here as the motor locks. As the motor locks, we can also see that it sends the email to the authorized address, which notifies the parent that the child has put away their phone. As I say that, we can see me demonstrate how the phone is no longer accessible in any way whatsoever. Once the phone is locked, it's no longer accessible from the outside, which will prevent addictive users from being able to access their phones. Now we can watch the timer drop down to 0, which is when the toaster should unlock, releasing the motor before the magnet is deactivated, unlocking the phone. We can conclude this demo by seeing that the phone has reached 80% battery. In the event of emergencies, there is an NFC system which will unlock the phone and release it before the timer ends. It won't accept any random NFC chip, but only the one that has been set up, which in this case was Cameron Phun. As we can see, the motor is released and the phone is out.
I have my sister that did some user testing. So what did you think of our toaster?
I thought it was pretty cool. Like, I got to actually focus on my studies. Like, I put my phone away for once in my life. So that was pretty good. Could focus on my phone without getting distracted by my friends or like Instagram, things like that.
Alright, and was it easy to use?
Well, like, it's like a toaster. You just put the phone in, press a button, and you just set it to, I don't know, 2 hours and it's done. It was funny that it could scare me when it pops back up, but...
One of the design limitations of the device is the motorized lock securing the phone in place. Its small size means that it could potentially be broken or forced out of place, granting premature access to the phone. For future improvement, this could be made more secure by using a metal roller shutter similar to a garage door. Another limitation is the lack of a system to set up personal email notifications or add extra NFC tags. This is currently done by modifying the code of the underlying program, which is not a viable solution for general users. This could be remedied by creating a companion app for the device, which would allow the user to set up email notifications as well as add additional NFC tags. This app could also be used to remotely unlock the device as well as make the device's screen more customizable. Overall, the main current limitation of the device is the budget and quality of build. The materials available and means for production meant the construction build was not up to the quality of a factory-built device, the most notable improvements to be made being the outside housing of the device, the top door design, and the inside cable connections and management.